Our overall design idea is to build a three-tier architecture. It is divided into web tier, application tier, and database tier. The benefits of using a three-tier architecture are that it can be modular, and by separating the concerns of each layer, you can modify, test, and optimize each layer independently. This reduces dependency between layers, making it easier to modify or add functionality, making maintenance and troubleshooting simpler.
First, we create a VPC, which provides an isolated virtual network environment and allow users to define their own private IP address ranges, subnets, routing tables, and network gateways. This helps enhance security and protect users' data and applications. We divided the resource into two available zones, and each available zone was designed to be isolated from other available zones to ensure that single point of failure would not affect the entire system. If one available zone fails, for example, due to a power outage or network problems, other available zones can still operate normally. Secondly, using multiple available zones can distribute traffic and workloads more efficiently. Elastic Loading Balancer can achieve this effect. We will also mention it later. Under the three-tier architecture, we isolate each tier based on subnets, such as web tier subnet in web tier, app tier subnet in application tier, and database tier subnet in database tier. In this logical layering, we clearly know which neighborhood is responsible for certain subnet. The web tier public subnet is connected to the Internet gateway to allow instances in the subnet to access the network. App tier private subnet connect to net. Our net connect to the public subnet. After the net device receives the request from the EC2 instance, it will rewrite the request to its own public IP address and then send the request to target service in the internet. So instance in this subnet can access the internet through net. Database tier private subnet also as a storage layer. We do not allow it to access the internet, so we do not need to connect to net.
For ACLS, we use the default settings. And for inbound rules and outbound rules, we allow all traffics to pass through, and more accurate security settings is set it up in the security group. Security group are a crucial part of cloud computing. I'll go over our security group setup and the key role they play in our architecture. So first, let's discuss the bastion host, which is the first line of defense for network security, and the only host that can be accessed directly from the public network. To ensure the security, we have set up a security group called Bastion Host SG that only allow SSH connections. This means that only authorized users can access a Bastion host via the SSH protocol, and we've given access to everyone so far. And next, we have a load balancer, which is used to access HTTP and HTTPS requests from the external network and route them to our web server. To protect this crucial entry point, we create a security group called Load Balancer SG, which only allow all HTTP and HTTPS traffic to pass through. And in our app tier, we also have a security group called App SG. This security group allows the load balancer to access HTTP services on the app server, and also only accepts Bastion host connections to the application servers via SSH. The setup ensures the secure access to the application tier. And finally, let's talk about the database tier. We have two different database services, MySQL and Redis. And to ensure that only trusted entities can communicate with the database, we set up a security group called DBFG. This security group allows only MySQL and Redis traffic from the application tier to pass through, ensuring that the database services are isolated and protected. Now let me introduce our load balancer and the important role it plays in our network architecture. The load balancer is a key component in the security and performance optimization of our network, and it helps ensure that our application run efficiently and provide the best user experience. It allows traffic from two available zones to pass through, US East 1A and US East 1B, to ensure that our applications are always available. Our load balancer uses IPv4 addresses, which allow it to efficiently route and load balance HTTP traffic from external sources. In the load balancer settings, we configured the default behavior, which means that all HTTP requests from the outside go through our load balancer. It forwards HTTP and HTTPS traffic equally to specific traffic groups, which are instances located in two available zones. The security of load balancer is ensured by the above-mentioned security group.
In our cloud solution, Autoscaling is mainly applied at app tier. It provides elasticity, which means that it automatically adjusts the number of app instances based on actual load demand during load peaks. Also, you can save costs when load decreases. Secondly, Autoscaling has a quick response feature that recognizes and handles load changes within minutes. This ability ensures that our application remains stable during load changes without manual intervention. In addition, Autoscaling improves availability. By deploying application instances in different availability zones, we achieve fault tolerance. If one availability zone or one instance goes down, Autoscaling automatically directs traffic to other availability zones, ensuring uninterrupted service. Overall, Autoscaling at application tier increases the availability of our cloud solution.
In the web tier, we create an EC2 instance. This EC2 instance acts as a patient host. All users must connect to the patient host through SSH in order to connect to our application tier's instances. In the app tier, we create two EC2 instances through autoscaling. The first app tier instances is in the app tier US East 1A subnet, and the other one is in the app tier US East 1B. Here, we store our web servers to the app tier instances. Now we can connect to our app tier instance and see what is our web server. This path is the default path of the web server in Linux. We can see we have an index HTML file. We cannot access to the HTML directly. We have to access to the Elastic Load Balancer, and the Elastic Load Balancer will allocate which instance we have to go. We copy the load balancer's DNS, and we can see we can see the web page. We can refresh the page. We can see the app tier is changing from 1 to 2 and to 2 to 1. The images and the video came from the S3 bucket. from the diagram, we can see we do not want to other resources to access the S3 buckets except the CloudFront. We can see that CloudFront is the only resource to get the objects from the S3 bucket. The CloudFront provides a CDN server, which is a content delivery network that allows users from different regions to access the object quickly. Now we can copy the domain name. And we can copy the object name. So we can get the object file. We create MySQL database from RDS in the DB tier. The MySQL store all relational data from the app tier's instances. Let's see how to access the MySQL. We copy the endpoint and copy paste the command. We can see we connect to the MySQL. The Redis is an in-memory database. We can use the Redis for sending the SNS. And let's see how to access to the Redis. Here I write a Python script for accessing the Redis. We copy the primary endpoint to the host and run the Python script. And we can see the my cache value result.
In conclusion, we focus on high availability and scalability by creating a virtual provide cloud, which is here, and using a 3-tier architecture. We allocated and scaled resources appropriately to ensure that the system was always available. At the same time, we deployed critical components in different availability zones, which increased the fault tolerance of the system. Secondly, we mentioned IT cost management, which Bastion Station is a very critical tool. It acts as a secure springboard server that helps us manage access to restricted systems, increasing system security, reducing potential risks, and improving the efficiency of the IT resource management. Next, for the DDoS attack protection, we use Amazon CloudFront and the Elastic Load Balancer service that provides automated DDoS attack protection tech to ensure that our website is more difficult to attack. Additionally, for the approximately 300,000 visits, we use AWS Autoscaling feature, which dynamically increases or decreases computer resources as needed to adjust to peak loads while reducing costs. Finally, our architecture also focuses on the security of IT infrastructure. Using multiple security measures such as 3-tier architecture and security groups to improve the system security. To summarize, our cloud solution is built on the 6 pillars of AWS, focusing on the high availability, cost management, security, performance, efficiency, operational excellence, and scalability. This helps to create a reliable and a secure cloud infrastructure to meet growing business needs. Thank you.